So today we are going to learn how to find out the equivalent resistance between the 2 points of a ladder network. This is known as a ladder network or an infinite network of resistances. Each value of each resistance is R. Now, if you pay attention, you will see that this resistance R and this R, they are repeating themselves, right? They are repeating themselves. So, what we do in order to find out the equivalent resistance, what we do, we take one of them and else. If you take the rest of the circuit from this point to this point again this circuit will be same as the earlier circuit, because if you take some amount from an infinity, the value will remain infinity only, right? So this will again be equivalent to R equivalent, right? So these two resistances R and R remains R intact, and the rest of the circuit we can take that this is the value of the equivalent resistance, right? So again this is A and this is B point. Now we can easily solve this. We have seen that this R and Req are in series and with parallel with this R, right? So R equivalent again, value R equivalent, because RAB is nothing but R equivalent. R equivalent is R parallel plus so this is equal to R into R plus R equivalent by R plus R plus R equivalent. So this is R square plus R into R equivalent by 2R plus R equivalent. And this is R equivalent. So you get a quadratic equation. You get a quadratic equation which you have to solve here. And the quadratic equation is R into R EQ plus R EQ square is equal to R square plus R into REQ. So this equation is REQ square plus R into REQ minus R square is equal to 0, right? So now if you apply Sidracharya formula, you can find out the value of R equivalent. As R is known, R is a known quantity, the value of R is given, and R equivalent you need to find out. So if you apply Sidracharya, you get R equivalent is equal to minus R plus minus R square minus of minus 4 means plus 4 R square and divided by 2. So it is basically minus R plus minus 5 R by 2. Now as resistance cannot be negative, so R equivalent will be equal to root 5 R minus 1, I mean minus R by 2. So this is the value of equivalent resistance of that infinite network, right? But suppose, now see this circuit. In the earlier circuit, this was repeating, right? But see in this circuit, this part is repeating itself. This part is repeating itself, right? In the earlier circuit, this part was not repeating. In this circuit, this part is repeating itself. So we can redraw this circuit as one. We will take this one, we will keep this part, we will keep, and the rest we will take as one circuit. This again, barring one, all the rest can be taken again as R equivalent. So we have taken one, and the rest we have taken it as R equivalent, right? So the basic fundamental is to reduce this ladder network or infinite network into a smaller network and then find out the equivalent resistance, right? This is the basic method here. So this is A, B. You have one circuit we have prevailed, we have taken into consideration, and the rest we have taken again as the initial infinite circuit. So the equivalent resistance is again R equivalent. Now in this, again, what will be R equivalent? The resistance between these two, again R equivalent, will be equal to this one parallel, and both are in series with this. So we can write R plus R parallel R EQ. R parallel R EQ. See, this R and this REQ are parallel, right? And the whole of this is in series with this R, right? So this is R plus R into R equivalent divided by, again, oh, sorry, R equivalent, R plus R equivalent, right? And finally what you get is R square plus 2R into R equivalent by R plus R equivalent, and this is equal to R equivalent. So again you do the mathematics and you can easily find out the equivalent resistance. I am doing the mathematics for you. So again it is R into REQ plus REQ square is equal to R square plus 2 into R into R. So what do you see here? Again, we have a quadratic equation, R square minus R into REQ minus R square equals to 0. So in the earlier case, you saw that we got here plus R equivalent square plus R into R equivalent minus R square was equal to 0. Here you have got R equivalent square minus R into R equivalent minus R square is equal to 0. Again, you apply Siddharacharya, you will get your answer. R equivalent will be equal to R plus minus under root. Again, you will get 5 R square by 2. And here your answer will be root 5 R plus 1 plus, sorry, R by 2. Root 5 R plus R by 2. Negative you cannot get. Since root 5 is greater than 1, you will not get R minus root 5R. Okay. So your answer R equivalent in this case is root 5 R plus R by 2. In the earlier case it was root 5 R minus R by 2. Understood? So that's it for today.